This is an atom, and it consists of electrons that revolve around the atom in paths known as orbitals, and it also consists of protons and neutrons that form the nucleus. As we know, electrons possess a negative charge, protons possess a positive charge, while neutrons possess a neutral charge. Additionally, we understand that negative and positive charges attract each other. Electrons will be attracted to protons since they are larger, and there will be no attractive force between protons and electrons with neutrons. When two atoms get close to each other, close enough for their valence electrons to approach, the two atoms form a bond. This bond is also represented in diagrams like this. Protons have a radius that represents their electromagnetic force, which, in this example, is the attraction of the shared electron that forms the bond. This phenomenon is known as electronegativity. So, if we want to define electronegativity, it is the measure of an atom's ability to attract and hold onto electrons in a chemical bond. The second atom's protons also have a radius, so they will also attract the shared electrons towards themselves. Then, the first atom will attract the electrons towards its side, leading to a competition for those electrons based on their electronegativity. Assuming the left atom is more electronegative, stronger, the shared electrons will be closer to its side, making the left atom partially positive and the right atom partially negative. This difference in charges is also known as polarity and is represented by the following arrow. The tail of the arrow represents the partially positive, less electronegative atom, while the head represents the partially negative, more electronegative atom. It's important to distinguish between a polar bond and a polar molecule. To explain this, you need to understand that oxygen is more electronegative than hydrogen and carbon. In the water molecule, the bond between hydrogen and oxygen is polar, because oxygen is more electronegative and hence for the other bond. However, for a molecule to be polar, the overall molecule must have a non-zero difference in its charge. In this case, the resultant force is to the right, which means that the molecule is polar. In carbon dioxide, the bonds are polar but oriented in opposite directions, canceling each other out due to the equal electronegativity difference between the two atoms, which means that the molecule is nonpolar despite having polar bonds. To determine an atom's electronegativity, we must consider factors that affect it. The number of protons in the atom is a key factor, as an increase in protons leads to a stronger positive charge and thus greater electronegativity. Another factor is the distance between the atom and its orbiting electrons. Greater distance results in less force on the electrons and lower electronegativity. Scientists have studied these factors and others to establish a rule for the electronegativity of each atom. Electronegativity increases moving upwards and to the right in the periodic table, which makes fluorine the most electronegative atom, with a value of 4, while cesium and francium the least electronegative, with a value of 0.7. That concludes our lesson for today. Thank you for watching, and see you next time.